Okay, for this first example, the goal is to go through and use Laplace transforms to find a solution y of t for this differential equation. And what's unique about this problem is the fact that we really don't have a formula for g of t. We just know it's some function that we can use in further calculations. So the idea is that we get a general solution for an unknown g of t. So the first step of this process, of course, is to take the Laplace transform. So if we take the Laplace transform of this, we're going to end up with s times big Y of s from the y prime minus y of 0, which is b. And then we've got minus a times big Y of s. And the Laplace transform of lowercase g is just uppercase g of s. Now from here, we want to go through and do our usual process, which is solve for capital Y in terms of s. So we first factor out s minus a times big Y of s minus b is equal to big G of s. And then finally, we can move the b over to the other side. And then finally, we could divide through by our s minus a. And in doing so, we end up with y of s is equal to this right-hand side. And now we're going to break apart this right-hand side so it looks more familiar to us. So we're going to have first a 1 over s minus a times the g of s plus the fraction b over s minus a. And then from here, we can now use what's called the convolution theorem and take this product apart and write it as the convolution of the original two functions in terms of t. So if we take our inverse transform, we end up with now little y of t is equal to the inverse of 1 over s minus a, which is just e to the at, now convoluted with g of t, the inverse of big G. And then, of course, the inverse of that term back here is just b times e to the at. And if you look at the formula above this problem, you will see that this convolution can be written in terms of an integral. It's an integral from 0 to t of e to the a times tau multiplied with g of t minus tau d tau. And this is still plus the b times e to the at behind it. And again, our textbook is going to want this in terms of v. So when you put your answers into My Math Lab, you're going to want to make sure you put v's in places of these t's. So your y of t in that case would be y of t is the integral from 0 to t of e to the a times v gt minus v dv plus b times e to the at. And that would be your final solution then for y of t in terms of the function g of t and the other parts of the differential equation.